Hello dear students, welcome to my channel. Today we are going to discuss the chemical properties of phenol from the chapter alcohol, phenol and ether. We have already gone through some chemical reactions and the preparation method of phenol. Now we are mainly discussing the chemical properties. If you haven't checked this channel, subscribe now. The first property we are going to discuss today is Friedel-Crafts Friedel-Crafts reactions. So we have already discussed halogenation, nitration, and sulfonation, and this is also a part of electrophilic substitution. Electrophilic substitution. Due to presence of OH group, it is highly reactive than the benzene, and it follows the Friedel-Crafts reaction, which is phenol is treated with CH3Cl in the presence of AlCl3. It forms resolves, but the position is also important. The CH3 group attached to the ortho position plus CH3 group attached to the para position in this case. So we can say that ortho and para resols are known. Okay, so this is the reaction. The yield of the product is poor as ring alkylation takes place. To avoid AlCl3 must be used. So to increase the yield, AlCl3 must be used in this reaction. Not in a low amount, we have to use in sufficient amount to increase the rate. Next reaction which we are going to discuss is hydrogenation. The second reaction is hydrogenation. In this reaction, mainly phenol, again, because we are studying the chemical reactions of phenol, is treated with 3 moles of hydrogen in the presence of catalyst like nickel, H2Ni, right? And at 150 degrees Celsius, the temperature required for this reaction, it will convert it into this. So it will form cyclohexanol. So we have done the hydrogenation, and to remove the benzene ring, we have used this method, and it's a very easy method. Now, all those reactions were related to the benzene ring. The next part of this reaction is due to OH group. OH. Reaction due to OH group. In this, the first point we have to understand, the OH group act as a acidic nature, shows the acidic nature, and it shows the reactions like, suppose this is your phenol, right? So it will convert into phenoxide ion. It will convert into phenoxide ion and release the H plus. We can call it phenoxide, or also known as phenolate ion. Remember that. Now, phenol is acidic in nature due to formation of phenoxide ion, and this phenoxide ion is basically, you can see, resonance stabilized, because there is a benzene ring and there is negative charge on O. So this is resonance stabilized. So the formation of this ion is very useful. Let's discuss the first reaction, salt formation in the acidic nature of OH group. The phenol is treated with NaOH to form the sodium phenoxide ion. plus water molecule will be removed. Okay, so this is the salt formation. The second reaction which we are going to discuss is ether formation. The formation of ether. In this reaction, mainly the phenol is treated with CH2, N2, and it will give OCH3, that is anisole, plus H2S. Okay, so this CH2 will attach to this. The next reaction which we are going to discuss, if we have phenoxide ion, suppose this is your phenoxide ion, ONA, is treated with ClCH3. ClCH3. It will also give OCH3 product, but the result will be Na. Okay, I hope you are able to get it. The CH3 here. So it will form phenoxide ion and the reaction goes like that. The next reaction which we are going to discuss in this is acetylation. Acetylation. The reaction would be look like that. There is a phenol is treated with CH3CO, Cl, carbonyl chloride compound. It will form phenyl acetate. What will be the reaction looks like that? Phenyl acetate, O, CO, CH3 plus HCl will be, so phenyl acetate will be formed. The next reaction is your benzylation. You can subscribe the channel right now. In the case of benzylation, it is also known as Shorten Bowman reaction. And the reaction goes like that. There is a phenol is treated with ClCO. Okay. So either KOH and NaOH presence is there and it will form phenyl benzoate. So how does it look like? You can see that OCO plus HCl. This compound is called phenyl benzoate. Benzoate. Okay. The next reaction is with ammonia. 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 So in this reaction, oh, what is happening? Plus NH3, it will give in the presence of ZnCl2. Remember, heat it. It will give aniline plus water molecule. And this reaction is also known as, you can write down, Bochra reaction. So it's almost going to end. Some of the very important reactions are like Timent. We are going to discuss also. Those are the part of other reactions, but acidic reactions is last one is with P2S5. So phosphorus pentasulfide, what we call it? Phosphorus pentasulfide. Penta means 5 and sulfide ion. So phosphorus pentasulfide gives thiophenol. What is thiophenol? Let's med it. There is a 5 moles of phenol treated with P2S5 It will give SH 5 moles of thiophenol. What do we call it? Thiophenol. Okay. Plus P2O5. So this is just switch. Remember that action. This is the formation of thiophenol. And there are some other reactions which are a part of, and very famous reactions are also there. And we have a test of phenol. So it's a kind of one is also needed for a. We will start the next part of this reactions. We call it other reactions. Let's discuss one by one. Okay. So this is very important reaction. Price migration. Let me teach you how to do it. When phenol is treated with, when phenol is treated acylated, suppose CH3COL, CH3COCl, it will form ester, right? Then we will further heat it in the presence of anhydrous LCl3. It will give ortho and para acyl phenols. So we have ortho and para. You can write down the name, whatever I am saying. Ortho and para acyl phenols. Acyl phenols. COCH3. These are known as ortho and para acyl phenols. Acyl phenols. This rearrangement is called Fries migration or Fries rearrangement basically. At low temperature, para product is dominating. Okay. So this is the reaction. You should remember. Low temperature per para product is dominating. This is dominating. Remember also, if ortho not and para positions, the presence of electron withdrawing group. Electron withdrawing group, then reaction will not proceed. For example, if we say that the ester is formed, suppose OCOCH3. This is your ester is formed, this product. Okay. But there is a presence of NO2 here already. So this is electron withdrawing group. So in the presence of anhydrous LCl3, by heating, it will go no reaction because of the presence of electron withdrawing group at para position. You must remember that. I hope you are able to understand. We can go through some other examples also. Next reaction which we are going to discuss is Kolbe reaction. Kolbe's reaction. And this would be the last reaction of today's lecture. So ध्यान से देखिएगा. You have phenoxide ion is treated with CO2 at 130 degrees Celsius. It will form. The temperature will be 6 to 7 atm basically. COONA. Okay. This intermediate rearrangement will be happen and it will form OH. COONA. Rearrangement will be there due to rearrangement. In the presence of H plus, it will give salicylic acid, which is OH, COOH. Okay, it is named salicylic acid. So this is called Kolbe reaction in the presence of CO2 and arrangement is there. Thanks for watching.